at transforming equations, or usually this is called the vertex form of equation, and we're going to look at some problem solving. So they've given us a question that says a baseball was hit and the flight of the ball is modeled by the following function. So this is a function. It's not just height, but is it just height? Oh, it is just height. Yeah, sorry, not a function of height. Okay, so the height of the ball is equal to this equation, and t represents time since it was hit. Okay, so they're giving us a little list of questions here. And when looking at this, we'll have to be able to tell, the very first thing they want to know, what is the max height of the ball? Well, this is vertex form, so I'm going to write it again. And vertex form is written as y is equal to a x minus h. Is that right? You guys use h?
Mm-hmm.
Okay, squared plus k. And the reason they call it vertex form is because the x and y value of the vertex, so the x vertex and the y vertex, are essentially the h value and the k value. You can literally just pull them right out. And the vertex, I guess we should write it on the side here. The vertex is the max or min of any parabola. It just depends which way it opens. Okay, so for instance, if we have a rough sketch, if a parabola opens upwards, then this vertex is the lowest point, is a minimum. And if the parabola opens downwards, well then the vertex, which is the highest point, is a maximum. Okay, so we keep that in mind. So, max height of the ball, which means that this parabola, if it's a max, must be pointing downwards. And we can verify that. What's the a value of this equation?
-6.
Yeah, and so because it's negative, it is facing down. So that checks out. That makes sense. There is a max value. So we want to know the max height. Okay. Well, we know that t is essentially our x value, and t is representing our time. Okay. So the x value of the vertex is our time here, and the height would be the k value here. So let's find what the vertex is. The vertex coordinate. We take the opposite. So see how I have h, and here it's negative h. So we change that sign. So it'd be 2.5. And the k value, maybe I should have done that in blue so it corresponds a little better. And the k value would be the 38.5. So this is your vertex right there. You can literally pull it out of the equation. So the max height would be right here. The max height is 38.5. And usually they tell us, and in this question I didn't write it down, h is in meters, so I should have wrote that down. H is meters, and t is seconds. Okay, so this would be 38.5 meters. All we have to do is look directly at the equation to find the max value. Okay. I'm going to add an extra question in there. At what time? So how long after it was hit did it reach 38.5? Well, that's referring to the time, and the time tells us at 2.5 seconds is when it reaches 38.5 meters. Okay, so let's do a little rough sketch of a parabola here. Okay. This parabola is hit from some height, goes up, and then comes back down. Okay, this point here is our 2.5 and 38.5, the max, right? The max height. It hits some max point, and then it starts coming back down. So this point here would be 38.5 on the graph, and this is a rough sketch. And that point there would be 2.5. Height of the ball when hit. Okay. So when was it hit? Well, this is our t, or our x. Okay, this is our x-axis, and this would be our y-axis, or the height of the ball. And the ball is hit. It takes off when time is 0, right? The ball doesn't take flight until we hit it at the point of 0. So we take that equation and we plug in 0 for t. So let's take that equation. H is equal to -6. This is the t value. We're going to plug in 0 for t. Okay, t minus 2.5 squared plus 38.5 is our equation. So we replace t with 0. That's to find out when it was hit. Okay, so think of that as like the starting point. So we just got to work the algebra out here to find the height. -6, 0 minus that would be -2.5 squared plus 38.5. Okay, we're going to have to square that and then multiply by 6, which in our lovely calculator we can do. Can I do a negative? Yeah, I can. -2.5 squared, okay, gives us 6.25. And in this calculator, I can just jump to the next step. So I take my 6.25, that's what this is, and maybe I'll write it in. Negative 6 times 6.25 plus 38.5, okay? We take that 6.25 and we multiply it by negative 6. We'll get negative 37.5. So now we have negative 37.5 plus 38.5, and I'm going to tell you that that equals 1. So remember, height was in meters, so height of the ball when hit at 1 meter. That's the height. So approximately here, obviously this is not to scale, because if that's 1, that's 38. The ball was hit at 1 meter in height. Okay. When did the ball hit the ground? This is a tricky question, because there's a couple ways to do this. It's looking for when the height is 0. We can trial and error our way through this question to figure that out. What I'm going to do is I'm going to come back to this one. Okay. I'll put a little star. We're going to deal with D first and then come back to C. D asks, what's the height of the ball after 1 second? Well, it's really similar to what we just did. Instead of putting 0,
just plug in 1.
Exactly. So let's quickly go through that one so we see the calculation. 8.5. Okay. When we subtract that, we're going to get negative 1.5 squared plus 38.5. And I'm going to try to do this in a step here instead of 2. Negative 1.5 squared, 2.25, and then if I take that and multiply by negative 6, I get that value, okay? And then it's that value plus 38.5, so I'm doing it all together. And 25. So after 1 second, the height of the ball, 5's are always iffy, is 25. So if we were to kind of sketch that, after 1 second, let's assume this is 1 second, the height of the ball would be 25 meters. So it gets up there really quick. Okay, when does it hit the ground? Well, we know at 0 it's at 1 meter. At 1 second it's at 25. At 2.5 seconds it's at 38. Okay, so we can use some inferencing. If it around here, okay, it's 2.5 seconds. So probably it's going to take another, because they're symmetrical, another 2.5 seconds to be at 1 meter. On the way down, that is, right? So, which isn't quite the ground, but it'll give us a hint of time, okay? So if this is 2.5 and I double it, it's going to be, and we can test this, it's probably going to be 1 meter again at 5 seconds, okay? And all I did was kind of double the distance between here, okay? And we can double check that. And it will be on its way down at that point. So I'm going to quickly plug in 5 just to prove this, okay? Height equals negative 6. 5 minus 2.5, and here, this is why this is going to work out so well. Ready for this? I sound so excited. When you subtract it, you're going to get 2.5, and before we've already done, we did negative 2.5. And negative 2.5 squared is the exact same answer as positive 2.5 squared. So there isn't going to be a difference. So when I do all of that, we're going to end up at negative 37.5. And you can check it on a calculator and make sure, but I'm going to tell you that's the number you're going to get. And then, lo and behold, we're back at 1 second. Obviously, kind of on our way down now. So, at 5 seconds, sorry, not 1 second, we're at 1 meter. So that means a little past 5 seconds. So we can try 6 seconds. We can try 5.5. Let's test another. Let's test that 6 seconds and see what happens. And I get the feeling it's probably going to be like 5.5, but we'll test 6. 6 minus 2.5. Squared. And this is why I left this one till later, because it's a bit of trial and error at this point. There is a method to do it, but you guys haven't really got into it, so we're just going to go through something we're familiar with. And this becomes 3.5 squared plus 38.5. So again, I'm going to do that all on my calculator, all those steps there. Oh, come here, calculator. Okay, 3.5 squared equals that number, 12.25. Times our negative 6. Yeah, I guess it is. And then when we add 38 to that, we are clearly below ground. We're way below ground, okay? Ground would be 0 in height. So at 6 seconds, this ball has somehow driven deep into the earth, which we know wouldn't happen. It would just stop, right? So it's somewhere between 6 seconds and 5 seconds, and we can kind of like play with it and figure it out. Maybe it's 5.5. 5.5 would give us 3 squared, which is 9. So 3 squared. I'm just going to test it out to see if it is 5.5. Times negative 6. No, it's not. See, that's too far. So it's not even 5.5. So I guess the best way to really describe this is to go, it would be between 5 seconds and 6 seconds that it hits the ground. Again, you can find an exact answer, but it's a little farther into quadratics, and this is kind of more of an introduction to it. Okay.